So today we're going to talk about the unit circle. The unit circle is a special type of circle. It's a circle that follows this formula. Now if you remember, that's our formula for a circle, where in this case x squared and y squared tells us that the center is at 0, 0 and the radius is 1. So if you imagine the circle that I have drawn right here, that this right here is at 0, 0, and from here out is a distance of 1. And as long as you can remember that, okay, then we will be a-okay. So what I want to do is a couple things. First thing I would like to do is this. I want to label a bunch of points on the graph. Meaning, first thing, I want to come up with the circumference of this graph. Let's see if you remember what circumference is. Remember, circumference follows that formula 2 pi r. So in this case, if my radius is 1, that means the circumference is 2 pi. So if we go back to the unit circle here for a second, and let's treat this spot right here kind of like a starting point. And so if I were to ask you, to trace all the way around the circle, all the way around to here, what would that length be? Well, you would tell me the circumference, which is 2 pi. So that's what I'm going to put right here, 2 pi. Well, what if I asked you to trace from here to here? How far would that be? Well, that would be half the length, so therefore this would be pi in length. What about from here to here? Well, that would be pi over 2. And what about from here all the way down to here? Well, let's see. That would be, let's shrink this just a little bit. That would be 3 pi over 2. Well, eventually we're going to learn a lot of things about trig here and the unit circle and its value. The value of the unit circle is that it allows us to understand the wrapping nature of trig functions. And so within this circle there's certain points that we really want to know. And these are 4 of them. And we'll talk a little bit more about what we want to know about them. But for now, let's kind of keep going. What if I asked you about this point right here? Now just make the assumption that that point is halfway between the starting point and here. So from here to here, remember when we say this is pi over 2, that's the length from here to here. It's pi over 2 in length. Okay, so from here to here, if that's halfway, that would be pi over 4. Okay, another one that we want to talk about is one that's right about here. Okay, and that one right there is what we would call, now it's kind of hard to tell just by looking at my my circle here, but this is pi over 6. And another one that we want to look at is one that's right about over here, and this one is pi over 3. Now, a couple things just to review. When I say that this point right here is pi over 6, what I mean by that is if I were to take let's say like a measuring stick, and if I were to measure how far it is from here to here, it would be pi over 6 in length. So in other words, if the radius here is 1, let's just pretend like it's 1 meter, then the length from the starting point to here would be pi over 6 meters. So pi is a little over 3, so that would be about 3 over 6, would be about a half a meter in length. You know, if I were to ask you how far it is from here up to here, that would be pi over 4 in length, meaning that if you were to take a measuring stick, okay, that's how far it would be. Okay, now let's do a couple other things here. Let me put that back. So if we were to keep going, let's talk about pi over 6 here. If I were to, instead of just stopping and going from here to here and get pi over 6. What if I went another pi over 6 in length? Where would I end up? Well, where I would end up, if I went another pi over 6 in length, I would end up right here. Because pi over 6 plus pi over 6 is 2 pi over 6, which is also known as pi over 3. What if I went again? What if I added another pi over 6? Where would I end up? So pi over 6 plus pi over 6 plus pi over 6. So 3 pi over 6 is pi over 2. What if I kept on going? What if I added another pi over 6? Well, if I kept on doing that, pi over 6, 2 pi over 6, 3 pi over 6, and another one, 4 pi over 6. 4 pi over 6, if I reduce that, would be also known as 2 pi over 3. And what if I just keep doing that? What if I just add another pi over 6? Okay, well, I would get this point right over here, which would be, let's think about that, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. And what if I just kept on adding pi over 6's? 6 pi over 6, and then if I add again down here, 7 pi over 6. Let's just keep on going. Add another one. Right down in this space right in here, I'd get 8 pi over 6. Well, 8 pi over 6 can be reduced to what? Well, I believe it can be reduced to 4 pi over 3. Keep going. 9 pi over 6, which reduces to 3 pi over 2. 10 pi over 6 right here. Well, 10 pi over 6 will reduce to what? Well, I believe it will reduce to 5 pi over 3. And keep going. Let's go one more. 11 pi over 6. And if I go again, 12 pi over 6, which gets us to 2 pi, which is exactly what it's written. Okay? Now, let's talk. So you see we're starting to get some points on this circle here that are going to become really important to us. And we'll talk about why they're important to us here eventually. But I want to do that same idea again with pi over 4. Notice that we went from here up to here, and we said that's pi over 4 because that's the length from along this curve, pi over 4. But what if I kept on going? What if I added another pi over 4? I would get to here, pi over 2. Because pi over 4 plus pi over 4 is 2 pi over 4, which reduces to pi over 2. Let's add another one. Let's add another pi over 4. Well, I'd end up, boom, right there. And that would be 3 pi over 4. What if I add another pi over 4? I'd end up with 4 pi over 4. Add another one. I'd end up with 5 pi over 4. What if I add another one? 6 pi over 4, which is 3 pi over 2. Add another one. 7 pi over 4. And what if I add another one? 8 pi over 4, which is also known as 2 pi. And now, what you're looking at here are all the important points on the unit circle that we're going to talk about. Okay, it's a lot of them, but the nice thing is that all of them are related to each other in one way or another. Okay? Okay, so now what we're going to do next is this. I want to know what are all the coordinates of those points. So again, if you can kind of imagine, like this big circle that we just drew is on the xy axis. And if that's the case, I should be able to tell what are all the coordinates of all these spots. Okay? So the way we're going to do this is this. We're going to kind of start over with a cleaner looking circle here. So let's do that. Okay, so now we got a cleaner looking circle. So what we're going to do is this. We are going to talk about what are all these coordinates. So let's start with this one first. Actually, let's start with this one right here first. Where is that spot at? Well, again, if this is the center of your circle, then, and this is a unit circle, meaning the radius is 1, that means from here out to here is 1, so therefore this should be 1, 0. And then if we do the same logic with going up, the coordinates of pi over 2 should be 0, 1. Well, that's easy. And we could continue that on with pi over here and with 3 pi over 2 down here. But let's talk about some of these other ones first. What about pi over 4? How do I figure out what the coordinates of that are, or what the coordinates of that point is? Well, one way you could do it is this, is you could draw a triangle. Now that's not just any triangle out there, that's actually going to be a right triangle, but it's even more specific. You know, what are some things we know about this right triangle? Well, one, we know that this length, this hypotenuse length is 1 because it's a unit circle, and the radius, which this is a radius, is length 1. But also, pi over 4 is halfway between here and here. So if this is a 90-degree angle, halfway, okay, would have to be 45 degrees. Okay, well, that's nice. So if I know that's 45 and there's a right triangle, that means this is also 45. So then how could I figure out what this length is and what this length is? Well, one way you could do it is Pythagorean theorem. So since it's a 45, 45, 90 triangle, you know that these are the same length because it's an isosceles triangle. So you could do x squared plus x squared equals 1, which is 2x squared equals 1, which is x squared equals a half. And if you were to square root, rationalize, all that stuff, you end up getting root 2 over 2. And so instead of x and x, you can now say, well, this length is root 2 over 2, and this one is root 2 over 2. So, how does that help us? Why do I care? Well, I care because if I know what those lengths are, then I know the sides, or the coordinates. Because if this length from here to here is root 2 over 2, that means the x-coordinate of this is root 2 over 2. And if I know from here to here is root over 2, that means the y-coordinate is root 2 over 2. And I just figured out what the coordinates of that point is. Root 2 over 2 comma root 2 over 2. Hopefully that makes some sense. Now, here is kind of a nice part. Is what if we were to take, kind of imagine this triangle here, and flip it over to here. Just kind of imagine like we're going to take the whole thing and we're going to flip it over. So basically at this point, I'm going to talk about this point right there. Well, what do you think that point is? We just talked about it when we were labeling our unit circle. Well, that point right there is 3 pi over 4. And we can follow the same exact logic. We can draw a triangle. It's not just any triangle, it's a right triangle. It's a 45, 45, 90 triangle, meaning that this is 1, and that this is x, and this is x. And we can go through the same exact steps to come up with the fact that these two sides are root 2 over 2 and root 2 over 2. Now that tells us then the coordinates. The coordinates now are not going to be root 2 over 2, root 2 over 2, but rather they're going to be negative root 2 over 2, comma, root 2 over 2. Okay, hopefully that makes some sense. Because it's negative root 2 over 2 because you're going to the left. Remember, this is the center. Okay, this is the origin. You go to the left. Okay, so don't think of the negative as like it's a negative root 2 over 2. Think of the negative as like a direction. Okay, negative root 2 over 2 means go to the left, root 2 over 2. Okay? And we can continue that same process if you can kind of imagine now taking this triangle here and flipping it down. So taking this and down to here and talking about that point right there. Well, that point right there would be 5 pi over 4. Okay, so we could draw our triangle again, and we can come up with the coordinates of that point. Okay, and we can just keep going and going and going and going and coming up with those points, which, guess what, you're going to here in just a few minutes. Okay, and same thing, you could take that triangle and you could flip it over here, and you could then figure out what the coordinates of this point, which would be 7 pi over 4, would be. Okay, makes sense so far? Hopefully? Alright, well, let's pause here for a second, and we're going to clean up this unit circle again, and we're going to look at the pi over 6s and the pi over 3s. Okay? Okay, so I cleaned up a bunch of our work there. Now let's talk about the pi over 6s. Now, if we take that same logic that we did with the pi over 4s, and we draw a triangle. Okay, we once again get a right triangle. But the question now is, before we knew what this central angle right here was, but now if it's pi over 6, what do you think that's going to be? Well, let's see here. If pi over 6, that essentially means it's 1/6 of the way from here to here. Well, from here to here, that would be 180 degrees. So if this is 1/6 of the way, you could imagine this being 30 degrees. So if that's 30 and this is 90, therefore this has to be 60. So we have a 30, 60, 90 triangle. And remember, the lengths of those were what? How did we come up with those? Well, I believe they were x, 2x, and x root 3. So the question becomes, which is which? Well, what you can do then is, let's start back with information we know. We know that this is 1 right here. Well, that's opposite the 90. Okay, so then what's the 30 going to be? Well, let's see. I believe, if we recall, that opposite the 90 was our 2x. Okay, opposite the 30 was our x, and this was our x root 3. So, if we're trying to figure all that out, then that means that if 1 is 2x, that means the x has to be a half. And if that's the case, then this over here, the x root 3, would then have to be 1/2 times root 3, or just a little simpler, root 3 over 2. So what does that do for us? Well, remember, what we're doing here is we're figuring out the length from here to here, we said is root 3 over 2. That's also known as the x coordinate. And then the length from here to here is 1/2, which is also known as the y coordinate. Just like that. And guess what? We can go through and we could just, pardon me, just like with the 45 or the pi over 4 triangles, we could take this pi over 6 and we can move it over to here. Okay, and if I did, we can kind of imagine taking this and moving it over to here. Okay, we get this spot right there. Well, what is that spot? Well, let's see. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. We're going to be talking about. And so we would do the exact same thing. We're going to draw that triangle. Okay, and then we would go through, and once again, this would be 30, this would be 60, this would be 1, this would be a half, this would be root 3 over 2. So that would help us come up with those coordinates again. And again, just like with the pi over 4s, it's not going to be root 3 over 2 of a half, rather it's going to be negative root 3 over 2, positive a half. And we could do the same logic. We could move this down. I'm not going to do this all right now, but you can move this down to figure out what this one was. Remember, that's your 7 pi over 6. Oh. And then you could do the same thing by moving it all the way over to here to figure out that one over there as well. Okay, which again, I'm going to ask you to do here in just a few minutes. Last one that I want to talk about is the pi over 3s. So let me pause this, clean this up, and we'll go back to the pi over 3s. Okay, so let's talk pi over 3s. So if here's our pi over 3 up on top, so let's draw our triangle. Ooh, that's not very good. Let's try that again. Okay, so let's try and figure out that central angle, this angle here. So from here to here is pi over 3. Now let's remember, so that's a third of a pi. So from here to here is pi, so which is also known as 180 degrees. So a third of the way then would be 60 degrees, and this would be 30. So again, we get a 30, 60, 90 triangle. It's just that our 30 and 60 are in different spots. So this is still 1. So that means this length down here in the bottom would be half that, so it would be 1/2. And then this time, this would be root 3 over 2. And so therefore, we could come up with the coordinates that this is 1/2, comma, root 3 over 2. Pretty simple. And then, just like with all the other ones, we could simply take this and essentially transfer it over to here. So if you imagine this is 1 pi over 3, this would be 2 pi over 3. We would draw our triangle. This would still be 60, this would be 30, this would be 1, this would be 1/2, this would be root 3 over 2. So my coordinates would be negative 1/2 root 3 over 2. That should be positive root 3 over 2. Okay? And just like all the other ones, you should flip that down, and you could come up with the spot down here. You could flip it over and come up with that spot right there. So what I want you to do is this. You're going to take a moment, and you're going to go through and figure out all the coordinates of all the points we came up with originally. Okay, so give that a shot, and then at the very end, I'll have it done for you. So this is your final product of your unit circle. So if we kind of take a look and kind of go around, you notice here's your pi over 6, over here root 3 over 2 1/2, pi over 4 root 2 over 2, root 2 over 2, pi over 3 1/2 root 3 over 2. And if we were to just keep going around the circle, you'll see we have all of our different spots here. Okay. Now, one of the things that you're going to have to do is you're going to memorize. Yes, I said memorize. You're going to memorize all these different spots. Now, something that's going to be helpful to you, though, is to recognize that there's certain patterns. For instance, if you notice all the pi over 4s, all the pi over 4s are root 2 over 2, root 2 over 2. That's helpful. Now, just depending upon where they're at, will determine which sign, whether it's like, for instance, 7 pi over 4, root 2 over 2, negative root 2 over 2. Versus up here pi over 4, they're both positive. So that part's helpful to make things easier. Also, you notice that on the directional point, so the north, south, east, west, notice that this one, notice I labeled this as 0 and as 2 pi. Okay, because that point right there, if we were just to start here, we would call that 0. But if we were wrapping all the way around, it would be 2 pi. Okay? But anyways, my point being is that that one's at 1, 0. The other directional point up here at pi over 2, 0, 1. Pi, negative 1, 0. 3 pi over 2, 0, negative 1. Now the pi over 6s. Okay, let me kind of give you my little hint, I guess, for the pi over 6s. Notice all the pi over 6s here. This one's root 3 over 2 1/2. This one's root 3 over 2 1/2. Here's another pi over 6, root 3 over 2 1/2. Pi over 6, root 3 over 2 1/2. Okay, so that's the first thing. Now, and what I always remember is this, is that every time that I have root 3 over 2, okay, I also have a half to go with it. Even up here with pi over 3, notice pi over 3, 1/2 and then root 3 over 2. Those two go together. Okay, over here. Notice, 1/2 and root 3 over 2. Root 3 over 2, 1/2. They always go together. Now, how do I keep track which one is which? You know, which one's root 3 over 2 1/2 versus 1/2 root 3 over 2? Well, the way I always remember it is this. I always remember it with the x-coordinate. So if you remember root 3 over 2, 3 times 2 is 6. So that always reminds me that, oh, all right, every time I have pi over 6, root 3 over 2 is first, because 3 times 2 is 6. Same thing here with pi over 4s. I always remember that root 2 over 2, because 2 times 2 is 4. Now, pi over 3 is not exactly the same, but it's kind of the same idea in that I always remember that it's 1/2 first, because 1 plus 2 is 3. So essentially, every single time that someone, if I were to ask you, okay, well, what are the coordinates of 5 pi over 3? As soon as I know there's a 3 on the bottom, I know it's going to start with a half, and I know root 3 over 2 goes with it. So it's a half root 3 over 2, and then I just have to think in my head, where is 5 pi over 3? Well, it's down in the 4th quadrant, so, pardon me, if we take, so if we look at 5 pi over 3 sitting right down here, there we go, sorry, that again, I know it was 1/2, and then it was negative root 3 over 2. So these are things that you need to really take some time to remember. It becomes very helpful as we go through this chapter for you to know those things, not have to think about them. All right? So that's a lot of stuff regarding the unit circle, but it's incredibly important. So hopefully all this stuff will help you, and hopefully you'll be able to apply these things as we go. Here.